So a ray of light in air travels across a flat boundary into glass. The angle of incidence is 51 degrees. The angle of refraction is 29 degrees. In the space below, draw a label diagram to illustrate this information. So we're just required to draw the boundary between air and glass. So let's draw a straight line using a ruler. Now you're being told that it is traveling from air into glass. So the angle of incidence there is 51 degrees. So I want to draw, the first thing that you do is to draw the normal. To draw the normal, there are two ways you can able to do. You can either use a protractor. After identifying a given point, you use a protractor at that particular point. Then you mark that point there. So when you connect this point and this, will give you the normal. Or if you can able to use the longest line, like this one here, let's say 2, and then you ensure that long part there is on the line that you've drawn. This line here is along this line. Then the line that you're going to draw here must be 90 degrees to that. So just do that. So this must be 90 degrees, which you can also confirm. That is 90 degrees. You can go to see. Now we're going to draw the so remember, the angle of incidence and the angle of refraction, they are both measured from the normal. So this surface here, this is air, then this side here, glass. So I'm going to measure 51 degrees. So I'll use the inner one. So 51 degrees. That will be somewhere here, this particular part. Then you draw it once. So there is the incident ray. This angle here, we have measured this is 51 degrees. That is the angle of incidence. Then this ray is going to be refracted by the glass, such that the angle of refraction is 29 degrees. Once again, the angle is measured from the so of course this is 180, so that means you want to use the inner scale. So 29, can you see? So this is 20, 25, 29 is here. So use your ruler, connect this. Then you draw once. So this is the refracted ray. This is the incident ray. This is the angle of incidence, the angle of refraction, which is 29 degrees. And that is what you're expected to do. Now this part, calculate the refractive index of the glass. The refractive index of the glass, we have been given the angle of incidence and the angle of refraction with respect to the glass. So we know that refractive index is given by sine I over sine R. And then this ratio will be sine of 51 divided by sine 29. So this, so sine 59 is equal to that divided by sine, sorry, that was sine 51, so sine 51 is equal to that divided by sine 29. So we get 1.6. This gives us 1.603 into two significant figures. That will be 1.6. You can able to see there is a ratio, so there is no unit. Now, a ray of light in glass travel towards a flat boundary with air. The angle of incidence is 51 degrees. This ray does not emerge into the air. State and explain what happens to this ray. So the ray of light undergoes total internal reflection. Why? Because the angle of incidence in glass is greater than the critical angle, and that will be, you'll be awarded 2 marks for that. Now, question number 7, you're being told that the figure shows a ray of monochromatic red light in air incident on a glass block at an angle of incidence of 50 degrees. Now state what is meant by monochromatic light. Now, monochromatic light is a light of, this is a light of single frequency or wavelength. Now remember, the white light is a spectrum of different colors of light, Roig beam. And these colors of white light, they can able to be separated or they can be dispersed because they travel with different speeds in different medium. And the reason why they have different speeds is because they have different frequency or different wavelengths. So that makes them to be having different speeds in a given medium. Now, for this red light, the refractive index of the glass is 1.52. Calculate the angle of refraction for the ray. Calculate the angle of refraction for the ray. Now, so we know that refractive index is given by sine I divided by sine R. So the refractive index here is 1.52. So 1.52 is equal to sine I, that is sine 50, divided by sine R. So making sine R the side of the formula, so we'll have sine R to be equal to sine 50 divided by 1.52. So what we do is just take this side and then bring this on this side. So that is that. So once again, we use a calculator. So this, so sine 50 is equal to that divided by 1.52. We get 0.5039 blah blah blah. So now what we do is just to find the sine inverse of the answer. Remember what you're getting, let me just write it. So sine R is equal to 0.50397667. This is sine R. Some students leave their answers this. Now R will now be the sine inverse of what we got. So sine inverse, that is shift, then sine of the answer, and we get 30.26344082. Of course, we don't try to answer that way. We'll able to give our answer in appropriate number of significant figures. The angles is always given to 1 decimal place, so that will be 30.3 degrees. Okay, or you can just give us 30 degrees when you round off into 2 significant figures. Now, without measuring angles, use a ruler to draw the approximate path of the ray in the glass block and emerging from the glass block. Now, for this particular question, we are not required to draw them into scale, but of course, we're just going to do some sketch here, and the kind of sketch must be appropriate one. So look at this. Our expectation is this. This is glass. Glass is optically denser than air. So we expect this ray of light to be refracted towards the normal. So, such that the angle of incidence should be greater than the angle of refraction. Now, when this ray of light, after refraction at this particular point, because it's now traveling from glass to air, if you're supposed to draw the normal here, we're just going to sketch that, measuring the normal. Then the angle of incidence, the angle of refraction, of course, now the angle with which it leaves the glass will be equal to 50 degrees. That means the way it's going to be refracted should be somehow parallel, not somehow actually, but should be parallel to this. So by the look of the eye, if I draw this, it should be parallel to this. So that is how you got 2 marks. Now, the red ray in the figure 7.1 is replaced by a ray of monochromatic violet light. For this violet ray, the refractive index of the glass is 1.54. The speed of light in air is 3.00 times 10 power 8 meters per second. Calculate the speed of the violet light in the glass block. So, this is another way of calculating refractive index. So refractive index is given by speed of light in air or vacuum over the speed of light in that medium. Now, refractive index is 1.54, which is equal to 3.00 times 10 power 8 meters per second divided by V. So if we cross multiply, so this times this times this, we'll able to have 1.54 times V, which is equal to 3.00 times 10 power 8 meters per second. Divide both sides by 1.54. So this cancel this, so therefore V, which is the speed, so 3 times 10 power 8 divided by 1.54. That gives us 194,805,194.8. Now we can able to see the values we've been given here is into 3 significant figures. So our answer will be into 3 significant figures. So this will be 1.95 times 10 raised to power 8 meters per second. Now use a ruler to draw the approximate path. Of course, this is also about sketching. Path of violet ray in the glass block and emerging from the block. Make sure this path is separated from the path drawn for the red light in A Roman 3 above. Mark both the path of this path with the letter V. Okay, let's go back to the diagram and see. Alright, now for us to draw the path for the violet, we need to know that, I know, if you look at this ROIC beam, now red light has a wavelength of about 700 nanometers. Violet has a wavelength of about 400 nanometer. So violet is refracted more than the red light. So we are being told that the violet will maintain the angle of incidence, but then this glass is going to refract violet more than the red. So we expect something like this. It's just an approximation. Just an approximation. Once it is there, it will follow the same. So the way it's going to be refracted should be parallel to this and also the other one. So approximately, this is what we expect. This is what we expect. And of course, so this is V, this is R.